The method we're going to look at for solving logarithmic equations now is going to look very similar to one we've already used. In logarithms, we're going to call that the one-to-one property. Again, we will start with an algorithm, and the first thing we're going to do is we're going to look at an equation in the form log base b of m equals log base b of n. Now let me stress that this form, using the one-to-one property, involves that we have to have a single logarithm with a coefficient of 1 on both sides. That's the only time I can use this. Then we're going to use the one-to-one property. This is very similar to what we looked at with the finding a common base in solving exponentials. If log base b of m equals log base b of m, since they have the same base, they have to have the same product. So m has got to equal n. Then we'll solve for the variable. Again, always check to make sure that your solutions are feasible, that they are actually in the domain. When you look at this equation, you may initially say there's no way you can use that because you said you have to have one log with coefficient 1 on both sides. Yes, I have 2 over there, but that's okay because I know how to condense. I can condense and write them as 1. So this is the natural log of x minus 3 equals natural log of, when you divide, you subtract, there's that saying again, of 7x minus 23 over x plus 1. Okay? Because I have the natural log on both sides, the object there, the of, must be equal. So x minus 3 will equal 7x minus 23 over x plus 1. So I want to multiply both sides by x plus 1 to get rid of fractions. So x minus 3 times x plus 1 equals 7x minus 23. Then I'm going to FOIL this out. That would be x squared plus 1x minus 3x, that's minus 2x minus 3 equals 7x minus 23. So I'm going to subtract 7x, so that's going to be x squared minus 9x. And I'm going to add 23, so that'll be plus 20 equals 0. I can factor this into x minus 5 and x minus 4. So I get that x is 5 and x is 4. It can be either one of those. Again, though, I have to check and make sure. So I say 5 minus 3 is 2. He's good there. 7 times 5 is 35 minus 23. Well, that's going to be positive, so he's good there. And 5 plus 1 is 6. He's good there also. Check my 4. 4 minus 3 is positive. 28 minus 23 is still positive. And 4 plus 1 is still positive. So in this case, believe it or not, both guys work. I get to keep them both. So don't always assume that you're going to have to throw one out, but always check just to be sure.